Remember yesterday when we were doing prime factorization? Do you remember?
Yeah.
Okay. We did prime factorization with repeated division. We're going to go through that same concept today. Exactly the same. But we're connecting it to the irrational numbers that we've been working with. Remember the real numbers that we have? We could have rational and we could have irrational. And so irrational numbers are the ones that kind of showed up a lot of them showed up in the radical forms, like the square root of 2 and the square root of 3, and if we punch it in our calculator and we don't get a nice number, then it's considered irrational. So we're going to start all of these the same way. I'm going to get my calculator out and I'm going to do the square root of that value. And so if you don't remember where to find it on your calculator, just let me know. But on these blue ones, you find the square root above the squared, like the little blue. So I have to hit second squared, and then the square root will show up, and 242, and hit equals. So the answer I get is 15.5563419. It probably goes on and on and on forever. Is this a rational number or an irrational number? Irrational. And if it's irrational, I need to simplify the radical. And to simplify the radical, I do it by pulling out all of the prime numbers. So I'm going to start, I move my division down, and I put the 242 in, and I start with the smallest prime number. What's the smallest prime number? 2. So I see if 2 goes in here. So I plug it in my calculator. I do 242 divided by 2. What do I end up with?
121.
121. So that worked. Then I'll check to see if 2 goes into 121. Does it?
No.
No. So I'll try 3. Does 3 go into 121? No. Then I'll try 5. Does 5 go into 121? No. What's the next one? 7 is the next prime number. Does 7 go into 121?
No.
Nope. And you can tell, again, just by taking 121 divided by 7, it doesn't work. So I'm going to keep trying. What's the next prime number? 11. Does 11 go into 121?
Yeah.
Oh, yes, that one worked. So I'll divide by 11, and I get 11. 11 is prime, so I stop there. Now, what I have for this answer is its broken down form. 2 times 11 times 11. And this is what I look for. Every pair that I find comes out as 1 in front. So this pair of 11s comes out in front as 1, and the 2 will stay in because it doesn't have a pair. This is my answer. So I'm going to be doing the repeated division and looking for pairs. So I'll start number 2 the same way. I want to see if this is a perfect square. I want to see if this is rational or irrational. So I go second squared 486. It comes out as an ugly decimal. Therefore, I have to break it down. So I'll put my division off to the side. I put 486 down, and I start dividing.
Divided by 2.
Divide by 2.
243.
243?
Yep.
Okay. Try 2 again.
No.
No. Try 3.
81.
3 and 81?
81.
Great. Okay, 81. So try 3 again. I keep trying until 3 doesn't work anymore.
27.
Does 3 work again? Yep, okay. Try 3 again. 9. Try 3 again.
3.
Am I down to a prime number? That's when I stop. Now this is how I write it. I need a long one there. I have a 2 times 1, 2, 3, 4, 5 threes. Don't forget the top one. So 1, 2, 3, 4, 5 threes. And then I start circling the pairs. So here's a pair of threes. Here's another pair of threes. Do I have any more pairs? Nope. So what happens is 2 threes come out and 2 times 3 stays in. Because I was able to take more than one thing out, I'm going to multiply those two things together. What's 3 times 3? 9. Beautiful. Because there's more than one thing left in, I'm going to multiply those things together. What's 2 times 3? 6. That's my final answer. So repeated division, break it down, look for pairs. Let's try another one. I start by seeing if this is rational or irrational. What do I have?
Irrational.
Irrational. It came up ugly. So I'll start my breakdown. What do I get? 2. How many times does 2 go into 500? 250. Divide again by 2. Does it work?
Yeah.
125. Divide again by 2. Does it work?
No.
No. 3 doesn't work? 5 works? Okay. What do I get?
25.
25. So I divide again by 5.
So equals 5.
5. I'm down to my last prime number written. So inside I put what? 2, 2, 5, 5, 5. Beautiful. And then I start to look for pairs. I've got 2 2s, 2 5s, no more pairs. What goes outside? 5 and? Yep, for every pair, 2 and 5 go outside. What goes inside?
5.
That one that didn't have a pair. What's 2 times 5? And that's my final answer. All right, I need your help. What's the first thing I do here? Check to see if it's, check to see if I can get a square root out of it. So second square root, 2025. Look at that. Is it rational or irrational?
Rational.
It's rational. So all I have to do is write that answer down. I'm done with that problem. So that's why checking it is a helpful thing to get started.
How do you do that?
All I did was, in my calculator, I did the square root key. Can you see that up there? And then I did the number, and it was 2025. On your calculator, I think you enter the number, and then do you have a square root key on your thing?
Yeah.
Okay, so you enter your number, then hit the square root key, and tell me what shows up.
41. Why'd you do that? 0,
Oh.
0, 2, 6, 2.
Check what you plugged in again, 2025. Bless you.
Yeah.
2025 square root.
2100625.
Oh, no. That one. Yeah. Okay. So we've got 2 left. What's the first thing I do? Check it. So second square root of 896, rational or irrational? Irrational. So that means I've got to do the breakdown. So I do 896 and divide. Where do I start? Always 2, right? Does 2 go in there?
Yeah, 448.
So 448, okay? Then I try 2 again. Does 2 go in again?
Yes.
It does. 224, okay? Then I'll try 2 again. Does 2 go in again?
Yeah, 1.1.
1, what is it?
112.
112, okay? Does 2 go in again?
Yeah.
56. Does 2 go in again?
Yes, 28.
Holy cow. Does 2 go in again?
14.
I don't like that. I didn't know you could count that.
Does 2 go in again?
Yes.
Whew. Does 2 go in again? No, 7's prime. So repeat it.
It went off my.
So now, yeah. 1, 2, 3, 4, 5, 6, 7 2s.
2, 3, 4, 5, 6.
And a 7.
How many teams?
I counted 7. Did I count right? Oh,
Yeah, you're right.
that's okay. Yeah, 1, 2, 3, 4, 5, 6, 7, and a 7. Okay. So start circling pairs. 1 pair, 2 pairs, 3 pairs. How many 2s go out? 3. Because I circled, bless you, 3 pairs. So 2 times 2 times 2. What's left in?
2 times 7.
2 times 7, whatever didn't get circled. Right. Remember, you're always looking for pairs because that's how a square root works. So what is 2 times 2 times 2? Beautiful.
12.
I heard somebody say 14. Yep, good.
I heard someone say 12.
I heard that too, but I also heard 14, so I went with the right one. All right, we're down to our very last problem, you guys. The last one that we're going to do together, and then I'm going to let you try a few on your own. What's the first thing I want to do? Check it. Second square root of 486. Is it rational or irrational? Oh, 468. Second square root of 468. Is it rational? It's irrational. Okay. So here we go down on the bottom again. Do my division. Start with 2. 2 is 2, 3, 4. 2 again. 117. 3. Go in order. That's 39. Okay. Try 3 again. 13. Try 3 again. 4. No, I don't need to try 4. 5. No, can't do any more because it's prime. Perfect. Okay, so this is underneath
2 times 3.
2 times 2 times 3 times 3 times 13. Start circling the pairs. A pair of 2s, a pair of 3s. Is there a pair of 13s?
No.
Okay, what goes outside?
3 and 2.
1, 3, and 1, 2. What goes inside? 13.
So we 6.
6 times the square root of 13. Final answer. Beautiful. How do you guys feel about this? Good. Okay, good. I don't know what that means, Tyler. Same as yesterday.